Dear colleagues, welcome to the annual International Conference Automatics and Informatics 2023. The conference is associated with the Jonathan Assouf Days in honor of his birthday, 4th October, which was declared by the Council of Ministry as Information Society Day, Professional Fest Day of specialists on computer engineering, information technology, and automation. This year is more special. On October 4th, it was 120 years since the birth of Jonathan Assouf, who is the patron of the Society of Automatics and Informatics. The conference, Automatics and Informatics, has been held for more than 55 years and significantly contributed to the development of automation and computer science and engineering in Bulgaria. For the 4th year, the conference is co-organized by Jonathan Assouf Society of Automatics and Informatics with Technical University of Varna. Thank you very much for support and co-organization. IEEE by Bulgarian Section and Federation of Scientific Engineering Unions in Bulgaria. I would like to thank our co-organizers for their, this is the President IEEE in Bulgaria, Professor Valia Markova. I would like to thank our co-organizer for the wonderful relationship and the very good cooperation we have had. I also hope for a very good cooperation in the future. I would like to thank very much for two very important people, Associated Professor Nicola Nikolov and Professor Hristo Valchanov. 4 years we work together very successfully, and I hope that in the future we'll continue. The fact that the conference is IEEE cause significant greater interest in it. This year, scientists and researchers from 16 countries are taking part in the conference. During the 3 days of the conference, 2 plenary, 100 scientific reports will be given and 2 company presentations will be made. For first year, we organize the company presentation. Maybe next year will come more firms. Traditionally, the conference is under the patronage of the President of Republic of Bulgaria, and this year, Mr. Rumen Radev was kind enough to send us a congratulatory address. I will read the 3 passages from the congratulatory address. It is a real pleasure and privilege for me to congratulate you with the opening of the International Scientific Conference Automatics and Informatics 2023 and the 120th anniversary of the birth of the great inventor John Atanasov. On the occasion of the Professional Day of the Bulgarian Specialists in the field of the informatics and information technologies, I am grateful to address all established names who will take part in the International Scientific Conference Automatics and Informatics 2023. Your long-term efforts are the solid foundation on which today our country is developing this important sector at a remarkable pace and scale. I wish all participants in the International Scientific Conference Automatics and Informatics 2023 fruitful work and many new scientific achievements. In conclusion, please accept my heartfelt wishes for successful conference, establish fruitful contacts, good friendship, and spend a few unforgettable days in beautiful Varna. I would like to give floor of Vice Rector of the University, Associated Professor Hristo Nenov. Please.
So, on behalf of the management of the Technical University of Varna, we warmly welcome you to the prestigious conference Automatic and Informatics 2023. The meeting is evidence of our commitment to advanced knowledge and innovation. During this event, we will have the opportunity to interact with the experts and fellow enthusiasts which share a common passion in IT technology. So we express our deep gratitude to the organization of this conference and of the participant of the conference. And with open hearts and eager minds, let's make this conference successful. So once again, wish you success and good luck of the conference.
Thank you very much. Dear Professor Nenov, I would like to give floor of the chairman of Bulgarian section of Institute of Electrical and Electronics Engineer, Professor Valentina Markova, please.
Dear ladies and gentlemen, I would like to welcome you to the International Conference of Automatics and Informatics 2023, which is organized by Jonathan Asov Society of Automatics and Informatics and technically supported by Technical University of Varna, IEEE Bulgarian section, and Federation of Scientific Engineering Unions in Bulgaria. As a chair of Bulgarian section of IEEE and as a proud member of organizing committee of this conference, I would like to take this moment to extend my heartfelt congratulations and sincere gratitude to all the members of organizing and program committee who have worked tirelessly to bring this event to fruition. It is indeed an honor to be part of the event that shares the vision of advancing knowledge and innovation in the field of electronics and informatics. For 4 consecutive years, Bulgarian section of IEEE has lent its unwavering support to this conference, a testament to our commitment to fostering collaboration and knowledge exchange. I firmly believe that this partnership between IEEE and Jonathan Asov Society of Automatics and Informatics will continue to yield groundbreaking contribution to our field. This conference became one of the largest scientific forums in Bulgaria, with over 100 participants. This year has seen a significant rise in the number of international submissions reflecting the global interest and importance of our research. I'm proud to announce that with the support of IEEE, all the presented paper will gain visibility and accessibility through inclusion in the IEEE and Scopus databases. This initiative not only promotes the professional growth of our authors, but also ensures the worldwide dissemination of their valuable work. Bulgarian section of IEEE is deeply committed to fostering innovation, and we proudly support nearly 20 conferences annually. Our aim is to continuously shape and contribute to the cutting-edge advancement across various technical domains within the IEEE community. In closing, on behalf of the Executive Committee of IEEE Bulgaria, and personally, I extend my best wishes for a highly productive and successful conference. May your time here to filled with fruitful discussions, collaborative activities, and truly enriching experience. Thank you, and let us embark on this journey of knowledge, exploration, and advancement together. Thank you.
Thank you very much to Professor Markova for very good collaboration between two organizations, Society for Automatics and Informatica, and Bulgarian section of IEEE. I forgot to thank very much for one lady that helped in our conference. This is Associated Professor Mariela Alexandrova. I don't know who is. She's here. Thank you very much. Dear colleagues, we have tradition. This conference is more than 55 years. I was student maybe, or before student, I don't know, but this conference work. We have tradition to hear classical music before starting of the conference, please. Thank you very much to these nice ladies for the music. And at the moment we have to start our work. The first one is I would like to open the plenary session. And Professor Gan Chuvachkov, very famous man in science, I calculate this morning, 17 years she was professor in Japan. He was. And I will give any word for Professor Vachkov. Professor Gancho Vachkov started his scientific and teaching career in the University of Chemical Technology and Metallurgy in 1970 years. From 1996, Gancho Vachkov moved to Japan for a long-term career and worked there until 2012 year in the following 4 universities: Kitami Institute of Technology, Nagoya University, Kagawa University, and Yamaguchi University. During the period 2012 to 2015, he worked as professor and visiting professor in the University of the South Pacific, Fuji Island. Then, from 2016 till February 2021, he worked as professor and visiting professor in Baku Higher All School, Baku, Azerbaijan. The research interests of Professor Vachkov are mainly focused on field of soft computing, computation intelligence, intelligent control, learning algorithms for identification and anomaly detection in large industrial systems, intelligent methods for detection and deterioration and fault diagnosis of complex systems, intelligent data analytics, data compression and decision making, unsupervised and supervised method for clustering and classification of data sets, evolving system. In overall, Professor Vachkov has authored and co-authored about 250 publications in peer-reviewed international journal and international conference, and is author of 7 international patents. I would like to give the floor to Professor Gancho Vachkov to present a plenary lecture with the title Methods, Models, and Algorithms of the Computational Intelligence Analyzed from a Practical Point of View. Please, Professor Vachkov.
Hello, can you hear me? Yeah. Thank you, Professor Kosta Boshnakov, for so long introduction of me and my activities. I felt something uncomfortable to hear to the long story. Don't expect so much from me now because of several reasons. One of the reasons is that we have shortage of time in the very beginning of the conference, so they suggested me to shorten the plenary lecture to 30 minutes, so I'll try to do it. It means we have to finish at 5 minutes past 10, but I have 68 slides, so it will be the challenging job for me, but I'll try to do it. The reason of this conference, okay, I forgot to tell. Dear distinguished members and participants of this conference, this is a big honor for me to be here in front of all of you and to try to explain in a simple words some difficult topics which have some real application in the industry. Don't consider that this is the whole story. This is the story told from my point of view and my understanding. If I'm not 100% correct, it doesn't mean that I'm lying to you, but this is the level at which I understand these problems. So let's go further on. This outline I will skip because it will be a little bit different as a content. To tell you in the beginning, we are floating in an ocean of data. The data are all around us. We are, dying in this ocean if we cannot swim. It means if we are unable to process the data are meaningless. So the problem is that we have to not only take the data, save the data, but we have to process them in some way in order to extract some decisions, some trends, some observations about if the system is working normally or something abnormal is happening. This is like being the doctor of a patient. The patient in this case are the data, and the doctor is person who will tell if the system is in a good health or something wrong is gradually happening. We have two groups of data. Actually, there are more than two, but we can classify the data as a batch data, which we process at once. We collect some portion of data, we call it a batch of data or file of data, and we do some processing. But in the real life, we have also streaming data. It means the data streams which are continuously flowing to us from thousands of sensors, and still we have to process them. It means that the data are enlarging, ever enlarging, and we have difficulty in processing this data. So different methods can be used in order to analyze if there is some anomaly of the system or some big changes has happened. This is like, as I mentioned, like a doctor. Doctor see the data from observation of the human body and take some decision how the patient is in a good condition or not so good. Okay, so intelligent methods which we prefer to use in this talk are such methods which include some heuristic methods, not purely mathematical methods. So they are not always precise. They don't converge always at the global optimum, but still, as a humans, we consider the decision is reasonable. So we have to give up the pure mathematics, and because mathematicians are happy only when they get the pure and exact solution. As humans and engineers, we are happy when even we have achieved to improve the situation, but not necessarily to go to the global optimum like Everest, for example. Okay, this is one example from my long years in Japan. We worked 5 years with Caterpillar Mitsubishi company, joint company, between America and Japan, and they had a problem with, not problem, but they wanted to find a method which automatically detects if the construction machine is in a good condition or not. So we were given 5 excavators, which we can adjust to some way to simulate some faults intentionally and take different data from the different operation. And it seems that the data are telling us interesting story. They tell us that this operation is different from this operation as a shape of the data cloud which they produced. So it means that the problem of defining the fault in the system can be transferred into the problem of classification or recognition of one cloud from another cloud of data. For this, there are several methods which can be used. Our contribution in this main project was to compress first the data from these small pieces of this point to the bigger, how to say, balls. The balls, I call them neurons, but they can be called also in other way. And you see the distribution of the ball type data is similar to the original distribution. So we are achieving something like compression of data. I call it Nescafe production. So we granulate the powder of the coffee into granules, and then we keep only the granules, because granules are approximately, they have approximately the same distribution as the original powder. In such way, we're saving memory, and we also are achieving faster progressing algorithms to do this procedure. Of course, we're losing something. There is no free pizza, as you know. except in some conferences, this is included. Okay, it's a kind of a joke, but it means that we are losing quality, or there is some error in this type of compression, but we agree with this. Okay, so another example of the data streams which we take from a petroleum plant for actually a crude oil distillation process in Baku, Azerbaijan. I was there and we directly took some data. This is a well-known cracking process, and this is so-called stabilization column. We were allowed to take many data from their decentralized system for many months of working of system, and our problem was, can we guess if the system was working all the time in a normal case, or there were some anomalies during this period? To detect the anomalies, it's very tricky because which type of operation you consider as an anomaly? Normally, if something sharply jumps up or down, it could be said as anomaly. But there could be also a reason for that. For example, we are rearranging the parameters of the system and there is no failure at all. So this is a process which has to be analyzed. For example, if you see these two streams, can you guess that something wrong is going? Maybe around 4,000 sampling, something has happened. And, but in the other part, the situation is similar. Well, this is another type of data for the fans of baseball. In America, near Los Angeles, there is a big stadium, which is Dodgers baseball stadium. And there are many times matches of baseball between this famous team and another team, and then many citizens of Los Angeles go to the stadium, and highway is very crowded. So the intensity of the traffic is going like this, and some peaks means that this is the regular peak of the traffic, because this is about 7 p.m. or between 5 and 7 p.m. or in the morning. But other peaks are specifically in the cases when there is a baseball game. Baseball game is here, but here there is no baseball game. So if we have this data, we try to guess, do this data suggest that now they're playing baseball or not? This is like a classification. Is this traffic normal or abnormal because there is a baseball game? For example, our famous singer Grafa in Sofia make a big concert in the National Stadium, and in Saturday evening it was unusually crowded in the trolley buses and tram cars around the stadium because of this event. So we try to mathematically solve the problem. And why we are using this data? These are just test data for us to test some algorithms. Okay, there is also another type of data which are very difficult. This is the spatial temporal data. These are data we are changing not only during time, but also during the change of the location in the space. Typical example for this is the meteorological data. For example, this is a picture taken from a satellite on one cyclone. They call it typhoon in Japan. And it was in December 2012. Fortunately or unfortunately, I was there at that time. I was living here in the capital of Fiji, Suva, and it was around Christmas, and I was maybe the only person in the guest house, because the others have gone back to their own country, but Bulgaria and Fiji are long distances, so I stayed there. Okay, it is interesting to see what the surveillance system of NASA, which is called Giovanni, showed in this moment. You see, in October, situation was this, so it is hot because it's southern hemisphere. Then in November, it becomes a little bit hotter. You see, this is even hotter and hotter because summer is coming. So during during this cyclone, this was the sea surface temperature around the main island of Fiji. But if you look at these pictures of the same area, during the years 12, 20, and 21, you can see the color, dark red color is increasing, which may suggest that we have really a kind of global warming. So we can use this temporal spatial data to predict the weather, but how to make the model based on such temporal spatial data is a tricky problem. Okay, this is done by the data are taken from internet, from Giovanni software. You can find it in internet and extract any kind of data. Shortly speaking, we can say that we have several big classes of methods of the computational intelligence to process the data. As you know, these are supervised learning. It means learning by using teacher, unsupervised to process the data without teacher, but just finding only the main characteristics of the data. Then reinforcement learning is the coach training, in which you try to ride a bicycle and somebody tells you how to keep the balance and something, but in a very rough way. So this is reinforcement. It is mainly used in robotics control, for example, of Professor Fukuda. He's working, and also competitive learning. Competitive learning is multi-agent method in which many equal members by abilities compete to each other in order to get the most food in the area. So this is, to some extent, unfair for some of the agents because they will gradually decrease or even die, but the others will become richer and something, but this is the reality. So competitive learning is used, especially in this algorithm, neural gas algorithm, which use the method to compress the data. Unfortunately, I don't have a lot of time to explain the details. So when we try to distinguish one data from another data, this is not just distinguishing one data point from another data, but one cloud of data with another cloud of data. We have to take some general measure to distinguish how similar and how dissimilar are they. So this is the so-called similarity analysis. And if we are able to make a kind of formula which expresses the similarity degree in the frame of between 0 and 1, 0 means no similarity, like black and white. And full similarity means black and black or white and white. And all the other combinations are between them. For example, we can say that here similarity degree is 0.78, which means that this data and this data are quite similar. Not the same, but quite similar. Okay, again, this is the example. If you look here, you immediately distinguish that this operation is different from this. I'll tell you why. Because this is the RPM of the engine. This is the fuel consumption. Now we have a low RPM but big fuel consumption. What does it mean? The excavator is doing a heavy job. He's digging the soil or some stones, so it's heavy work. That's why we need a lot of fuel to run to the engine and low RPM. And this looks more like free condition or light action in which fuel is in the middle and RPM are high. Okay, RPM are high. It means we are like, he's just running on the road without a big load. But humans can do it because we have eyes. But how to do this by computer without using eyes is a tricky problem. So we can use the granulation for this method. Another thing, we can consider if our problem is how to how to detect the fault in the system. This is already the area of fault diagnosis. In fault diagnosis, we can use the so-called model, a fuzzy model, and usually, okay, I'll tell you, usually the model is from the type of fuzzy model, okay, fuzzy model, so sorry, okay, this, for people who know something about fuzzy, this is the structure of the fuzzy model, which consists of fuzzification, fuzzy inference, or taking decision, and defuzzification. The fuzzy model is not only model, but this is also a decision-making unit, decision-making, and that's why fuzzy is a very general method of taking decision. And one of the, okay, in some way I'm advertising myself now, because many years ago when I looked like this, not like today, and this is a very famous person, much famous, more famous than Michio Sugeno. Michio Sugeno produced the most famous paper about modeling, fuzzy modeling, in year 1985. And this model is called Takagi-Sugeno fuzzy model. This is universal approximator of any kind of data. I was happy to know him. This was taken during the banquet of one fuzzy IEEE conference in Imperial College in London, and this was the cruise in the Thames River, and I said to him, spoke to him. Unfortunately, he passed away 2 months ago, I think in August at the age of 83. He was really a very remarkable person and very, how to say, humble. He never looked proud, and he was a very, very good man, actually, together with his PhD student, Takagi. Takagi is already retired professor, but those years was his PhD student, one of the smartest. So we made some modification of this fuzzy model. These are the fuzzy rules. We decided to take only the fuzzy rules which have been built based on the data around them, because the full Takagi-Sugeno model needs all this data, all these rules, and even the rules which are meaningless, but they have to exist in the model. We decided to discard them and make some special algorithm. Let me skip all the details. They are given in some paper. And we tried to make a fuzzy decision about, is there a fault somewhere in the system or not? How we define the fault? The default fault is decided by comparison, one portion of data from the data stream with another portion which clearly represents something which has happened before. So we have something like database which says several types of faults that has happened before, and then we compare the current data portion, which we cut from the data stream, until we find something that is very similar. We put some threshold. For example, similarity more than 80, more than 0.8 means this is very similar to this case. In other words, it says we are almost sure that the current situation is very much similar to the fault number 3, which we have 6 months ago, and something like that. So this is actually supervised system based on the. So this is a representation of the typical data sets, current data sets, and this is the data set which represents the some fault. You see, if this is the case, I clearly say, definitely this is the situation. Here is a little bit like this, here is 0, because they don't have overcrossing, so they have nothing similar to each other. Okay, so we make the fuzzy model in this way. This is the response function. If we are in these coordinates, we we have full similarity, and here zero similarity. And this is the essential of the period. We applied this method to this system in which we took three parameters, one flow rate, one temperature, and one another temperature. So we had three data streams. And if we find that cause-effect relationship is broken between these parameters, it means something is happening in the system. Okay, so here, so this is the supervised system in which we detected 4 smooth areas from the process and 2 rough areas, and then we try to guess by using normal data, and the system truly detects that here we have high similarity in this area, high similarity here, but not here. So it means that we have detected some 3 suspicious cases in which we have something wrong. Here is more difficult case. Let's go to another method. Another method to solve the same problem is to use histograms. Histograms, it means density, not fuzzy model, but just density of data, and we get similar results. And we've continued to create an algorithm which detects the changes. By the way, changes can be fast changes and slow changes. Which are more dangerous? Both of them could be dangerous, but I can say slow changes are very dangerous. They are very slow. They are almost invisible. We are getting colder, unfortunately, day by day. But tomorrow, I'll look almost the same like today, but not 5 years later. So this slow trend is very dangerous. It can lead to a catastrophic situation. So how to find that something is going wrong? Okay, this is one way of extracting that some change has happened. For example, this point shows that something has happened in this case. Okay, all these portions above the threshold means that there is a change. There is a change which is significant change, and we have to take it into account. Here is another representation of small data clouds which represent pre-selected situations of some wrong cases. And now we built one 5-channel system, online monitoring system. It means 5 screens or 5 TV screens in front of the operator, and each screen is responsible for detecting of only one failure. So when the data are running, we say that number 1 means that the first stream has a failure at this moment. In the second failure is at this moment. The third is in this, because this maximum is close to 1. So when we detect something which is closer to 1, let's say 0.9 or something, it means be careful. We are very close to the failure. Conclusions, oh, excellent, 10 o'clock, I have finished. So I'll be glad to answer your question. Please answer, because if there is only silence in the room, I'm extremely unhappy. It means that it was a catastrophic presentation from myself. So that I welcome any kind of question from your side. By the way, the PDF and also PowerPoint presentation of my presentation is on this computer, and you are free to copy it and to contact me. Usually I reply within 2-3 hours, because I'm almost free, not engaged in teaching process now in the university, unfortunately, so that I'll answer you quickly. Thank you very much.
Thank you very much to Professor Vachkov. Please, if you have any questions. Professor Mengov.
Professor Vachkov, have you compared your methods
dangerous question. I have not done this. The reason is very simple. I am a fan of non-traditional, not pure mathematical methods, so that I'm weak to for using pure mathematical models. I know that some of them are excellent and they could give excellent results, but they will definitely crash if the data are with high noise with them, because they are very precise methods, but sometimes they cannot process the noisy or, let's say, messy or dirty data. So the problem, all the topic, all the center of my presentation is how to use the non-traditional methods of computational intelligence, which means using more intuition and heuristics to make computers to process the data based on the human knowledge. Sometimes human is superior. It doesn't understand very much the deep mathematics, but still he can solve the problems even faster than the computer. So unfortunately, you replace now academic Gurev, because if he was among us, he would ask me the similar question. Thank you.
Thank you very much, Professor Vachkov. Do you have any questions? Please. Въпроси питам.
Thank you so much. Very interesting research, and I think I have some ideas how to improve the efficiency of looking for anomaly regions with external data. For example, if our data cloud is connected to some driving route, then we have some anomalies. He will find them. But we have some different kinds of constraints, external constraints. For example, like this part of road is dangerous. This part of road is slippery, and so on. And additional external data and special constant regions will help improve the classification. We'll speak about this.
I got the idea and the problem that you are mentioning. You are right that in the real life it's very difficult to say which is the anomaly, which is not anomaly. And if you want to make the excellent solution, it will be the solution, his solution by using heavy mathematics. But because of the many constraints, he is speaking about constraints, sometimes the constraints are so many so that there is no ideal mathematical solution. And still we go to some suboptimal solution by taking human knowledge or human experience. This is actually the weak point of the computational intelligence methods, because they are not purely mathematical, they are more closer to the human thinking. But I could say this is not only their weak point, this is also their strong point, because strong point is that human never stops. He will give solution, give some decision, even wrong, but the pure computer will just stop working because of zero division, because of some other things. So the power of the human is actually in his weakness. So that we, at any time, we say something. Maybe it's not excellent, not the best, but we are saying we are not calm. Okay. Yeah, it could be improved. Maybe some fusion between the method that you are mentioning and more soft method, soft but inexact method about which I am speaking all the time, could be a good marriage. Why not?
Thank you very much, Professor Jotsov, for the question and for answer, Professor Vachkov. Can only one, Laskov, please. Yes. Professor Jagarov also. Yes.
I have a general question. So, as far as I understood, in practice, when we use machine learning techniques, most of the methods are heuristic. So, and probably there is a good reason for that, especially when processing huge amounts of data. So my general question, Professor, is how can we be sure that a certain heuristic method actually works? Because if we have a mathematical method, we can provide mathematical proof. However, many of the heuristic methods we cannot prove them.
We just give up proving. because of the heuristics, we know that we are vulnerable by proposing this method. And we agree with this, that sometimes our method will crash or collapse. But in the most of the cases, it will give the solution faster than mathematical method and less exact than the mathematical. We are making compromise. When you have a huge data and you want to use the excellent method, you have to work years to process them to go to this well-known global optimum. We say, no, I don't have so much time to work 3 years on this. I will work 1 month and I'll get 92% of them. And still it's okay. This is engineering solutions. So this is a balance between, do you want to be exact but to spend huge resources for this, or you make some compromise between them? I'm on the side of the real humans, which need to spend the other part of the time for other activities, for example. Thank you.
Thank you very much. I would like, but we have no time, I would like to close the plenary session. Professor Vachkov is here today. Yeah, every one moment.
Also, I'm all the time here. Please ask me any questions.
If you have, you can speak personally with Professor Vachkov. Thank you very much, Professor Vachkov. I close the first plenary session. We will start with scientific sessions. Thank you. Thank you very much.